We're going to work our way into it with graphing these. What is a way you know how to graph? What ways have we learned to graph so far? What did we do all semester or last semester? Slope, right? We did rise over run with linear equations. Now we're doing quadratic equations. What did the linear graphs look like? What did the slope-intercept form, what did those graphs look like? A straight line, right? Linear, okay? What do you think these quadratic ones are going to look like? Take a guess. Good guess. I see X. I see two X's. I see parallel lines. Any other guesses? A circle? It's not a circle. Okay. What else have we seen, though? We saw one other graph very briefly. Remember exponential growth and decay? We talked about those. Okay. Let's get to quadratic. With these, we're just going to start by doing an XY table. You're not going to do it the whole time, but we're going to do this to see what it's going to end up looking like. Okay, so with our XY table, let's pick X values. So look at their X-axis down here. We want to pick those. Throw one out. -1, I heard -2, -3. Let's do all of them. -4, -5, and -6. Doing an XY table, how can I figure out what the Y values are? What? What can I do with these X values to figure out the Y values? Yep, you plug all of them in. So if I plug in -1.
Oh, to that equation.
Yep, plug it into the equation. -1 plus 17. You can use your calculators. What's -1 squared? 1 times -1 is 1 plus 8 times -1 minus 8. Yep, -8. And then we have that plus 17. So for that we get 10. Okay, how do we find the Y value for -2? Same thing, plug in -2. What's -2 squared? -2 times -2? +4. What's 8 times -2? Yep, so if we have 4 minus 16, and then we have that plus 17, so we get 5. Same thing for -3, right? Go ahead and plug all of those in. So remember from these table of values, those give you your ordered pairs. So you notice 1 kind of goes off the graph up here. What does our graph look like? A what? A scatter, okay. Is there any way we can connect these?
Triangle.
So if I'm starting at my -1 point up here,
Oh my gosh.
follow, 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 what happens when I hit here? It starts going up, okay. So we go down, and then we curve back up. Look at your table of values. What do you notice about your table of values? Anything?
They reverse.
What do you mean they reverse?
It goes 10, 5, 2, 1, 2, 5.
Yeah, what do you think if I plugged in -7, what do you think that value is going to be? 10. Yep, does everyone notice that? I have 10s, 5s, 2s, and then I have my 1 point in the middle. So what do you think is going to be helpful with these? What do you notice about our graph? They're reversed. There's another word for it. We'll get to it.
Do I know the word? Let's start with.
S. You can think switch. We'll come back to it. Keep thinking about it. So if I look at number 2, without even only looking at the equation.
Symmetrical?
Yep. So back up a little bit. Now that you said that, symmetrical.
Yes.
Where is this symmetrical at? So symmetry means it mirrors each other, right?
-4. Where'd you get
Okay.
-4?
Right. Where'd you get -4?
That's where I took up.
Right.
Ah.
This point here. If I drew a line of symmetry right here, do you see that they mirror each other? So that will be helpful when we graph those. Okay. Without even thinking about those, looking at number 2, looking at what kind of equation it is. First of all, what kind of equation is that? What are these called?
Yeah,
Quadratic.
No.
Okay. What's the graph going to look like?
A triangle. Symmetrical.
It's going to look like a V or U. These are called parabolas. Write that paper down on your, or write that word down on your
I
paper.
spell this.
Yep, I'll write it.
Okay.
Parabola. These are called parabolas. Okay? Each graph that you create from quadratic equations should be looking like a parabola, which is a U. They could also turn upside down. When do you think the U could be upside down?
Negative.
What's going to be negative?
Positive x's. Negative y's.
When we were factoring, what did we care about with these? What did we care about what it had?
If the numbers.
We cared about the leading coefficient, right?
Oh.
So if our leading coefficient is negative, then it's going to be going down. Okay? Do you think there's an easier way than just doing XY tables the whole time?
Probably.
Do you want me to share it with you?
Of course. Yeah.
Okay. One more thing I want to talk about, though, is that domain and range before we get to the other method. Domain and range. What does domain mean? What values does it have to deal with? X or Y? X. Domain is with our X values. So we want to know our lowest possible X value and our highest possible X value. So if we're looking at X's, remember X's go left to right, correct? What is my least possible X value? On our graph, yes. But what if I add arrows?
I don't know. -10. I don't know. Then it can go wherever.
It can go forever, right? I could do -20 if I really wanted to, and it would still be a value. Okay, so what can we use as a symbol that goes on forever? Infinity. Yep, but since it's our least value, we want negative infinity. Okay, now think, what is my highest possible X value? Same thing on this side, right? We have arrows. Can I keep going? So what could we use for our highest possible? Positive infinity, yep. So our domain goes from negative infinity all the way to positive infinity. Okay, that's looking at my X values. Now our range, which values are those? The Y values, okay? Y's, do they go side to side or up and down? Y's go up and down. Okay, so what is my lowest Y value? What's my lowest Y value? Remember, we're talking about the graph.
Oh.
So my lowest Y value would be
-4.
1, right? Remember, we're looking at our Y-axis. Our lowest Y value would be 1. Does everyone understand how I got 1?
Yes.
Okay, so 1 is my lowest. What's my highest Y value? But,
Infinity.
right, it's going to keep going up higher and higher and higher. So our range would be 1 to infinity. Okay, So the only definite spot that we have for our domain and range is where? Where it changes directions. Okay, that's our only definite value. That's where we got our 1. Okay, we're going to do a lot more practice with this. Questions so far about the basics? Okay, now we're going to talk about something called the vertex. Okay, the vertex is where everything changed directions and started mirroring itself. Okay, so what I want you to do, underline or circle that equation right there. So we're going to locate the vertex, or where everything starts flipping, using that equation x equals negative b over 2a. I'm going to rewrite that down here. X equals negative b over 2a. Where do we think we get those b and a terms? From our equation. Remember we talked about this briefly? This is our a term, we have b term, and this is our c. Okay, so let's plug in what we know. What's negative b? Well, first start, what's our b? Negative 4, so what's the negative of this? Positive 4, we just want the number. So our negative b would be 4 divided by 2 times, what's my a value? Remember, we want the number. Negative 1, right? We have that negative sign out in front. So the b, I took the negative b, which is 4, and then I took 2 times our a, which we have negative 1. Okay. Now we just simplify that. We have 4. What's 2 times negative 1? Negative 2. 4 divided by negative 2? Negative 2. Now, what is important to realize is that x equals negative 2. So think of your xy table. I have x as negative 2. So how do we find the y value to that?
You gotta put it in the equation.
We put it in, right? Just like we did up above, we're going to plug this x into that equation. What do you have to be careful with when you do this one? There's a bunch of negative signs, right? Okay, so if you write it out, you have to be careful. We have negative, and then we have our negative 2 squared. Does that make sense? With that negative in front? We have negative from here, and then we have plug in negative 2 to x. And then we have minus 4 times negative 2 minus 6. So what's negative 2 squared? 4, and then we still have that negative. So we have negative 4. What's negative 4 times negative 2? Positive 8. And then we have minus 6. So put negative 4 plus 8 minus 6. What do we get? Negative 2. So that there, we just found our vertex. Okay, so plot that point on your graph. We have negative 2, negative 2. That point is my vertex. So why do you think it's important to find the vertex first? That's where the midpoint is, right? That's where everything starts to mirror itself. So what values can we pick to get our other values? Negative 1. Pick a value to the left and pick a value to the right. Now you don't have to do a bunch of values to find where your vertex is. Okay? So I picked, from my vertex, I picked a value that's to the left, and I picked a value that's to the right. Is our parabola going to go up or down? It's going to go down, right? Because of that negative out in front. Okay, go ahead and find your values for negative 1 and negative 3. What do you know about the values of negative 1 and negative 3? Go ahead and find them both, and then we'll talk about it. So what do you notice? What do you notice about my -1 and -3 y value? They're the same. Okay, go ahead and plot those. Remember, what did we say is going to happen? They're going to start mirroring each other, right? So, should those match? Yeah, so do you have to plug both of them in? Do I have to, if I find -1, do I have to plug in -3? No, because you know that they should match and mirror each other. Okay, so once you have those 3 points, you can draw your graph. Flip to number 2 real quick. Okay, she was asking about the leading coefficient and how that would change. So let's do our first step. What's our first step? Vertex. So if I have, what's my -b? 16 over 2 times a is our 2. Okay, so we have 16 divided by 4, 4. So if I use my XY table and I plug in 4, you got to think order of operations. So if I plug this in down here, I have 4 squared minus 16 times 4 plus 35. So what she was asking is how you solve this part right here. Writing it out like that, order of operations, what has to come first? Exponent has to come first, okay? So 4 squared would come first, so what's 4 squared? 16, and then you would take that times 2. Yep, so just do that exponent first. Yep. Does that answer your question? Okay. So on this one, what would your y-intercept be? 35. But is it on the graph? No. So that's when you would want to pick those 2 other points. Okay? If you can't use the y-intercept or you can't put it on the graph, that's when you have to pick 2 other points on the other side of your vertex. Does that make sense? Okay. To that back side. Now go ahead and read those directions. What does it want us to do first? Find the vertex. How do we find the vertex? Yep, x equals -b over 2a. What is my -b term? -4. And then 2, what's my a term? 1. Good. So now evaluate. I have -4 divided by 2, which is -2. What did that just give me? That's the x value of the vertex. So how do I find the y value? I'm going to plug it in. Yep. So plug in -2 into your equation to find your y. Anyone got their y value? So our y value is 2. So again, that just gave me my vertex, which you can think of as the midpoint. Okay, so go ahead and graph that. So -2, 2. Next, we were picking other points, right? Well, look at the directions. It wants us to find the y-intercept. What does that mean? Where it crosses the y-axis. So we want our y-intercept wherever it crosses here. What's my x value if I'm on the y-axis? 0. So I'm going to plug in 0 to all of my x's. What's going to happen if I plug in 0?
So it's going to be 6.
Right. How did you get 6?
You have to add 6.
Correct. So I'm going to plug in 0. So I have 0 squared plus 4 times 0 plus 6. Well, you notice multiplying by 0 always gives us 0. So you get your c value. So your c is always going to be your y-intercept. Okay, so you can go ahead and plot that. Our y-intercept is 6. Now, what do you know? How can we get that third point?
1.
mirror it, right? So if I know 2 spaces away from -2, I'm up at 6. So where's my other point going to be? -4, 6. And then go ahead and make your parabola. Where is the axis of symmetry at? Yep, it's that x equals -2. So our axis of symmetry is the same thing as our vertex. Okay, so the vertex, x equals -2, is the same thing as our axis of symmetry. So with that axis of symmetry, remember, it's mirroring each other. So here I was 2 spots away. On this side, I'm going to be 2 spots away. So looking at number 7, what is the first step in graphing that I want to find? The vertex. How do I find that? -b over 2a. That -b, we want to find the opposite of our current b. So our current b is what? -4. So what's the opposite of -4? +4. And then I have 2. What's my a? 1. So I have 4 divided by 2, which is 2. Okay? So if I have my xy table, I know 2 is my middle x point. How do I find the y value of that?
Plug it in the equation.
Yep, plug in 2 into our equation. What's 2 squared?
4.
4. -4 times 2? -8 plus 6. What'd you get for your y term? 2. Okay, that just gave us our midpoint. I'm going to go graph that. 2, 2. Okay, I saw 2 different ways. Some people picked values. Who picked values to plug in? So you picked like 1 and 3, right? Some people did that. What did other people do? The y-axis, or the y-intercept, right? So you can plug in values. Kara, what'd you get when you plugged in values? You got 3. So that could work. You got your other 2 values here. How would using the y-intercept help? It would find what's on the y-axis, which is, what's it always going to be? That c value. Okay, so we know our y-intercept is 6. So you want to find 6 on the y-axis, just like we did with slope-intercept form. So there's my y-axis. And then what other point can I automatically fill in? Yep, that 4, 6. Yep, if I have my axis of symmetry right here, it should be a perfect mirror image. And then last step, draw your parabola. Better than mine. Okay? Nice job with those. Any questions before I let you do the rest?